let's talk about tuberculosis and about its pathogenesis. Now, tuberculosis is a chronic pulmonary and systemic disease. Now, if you could remember, tuberculosis is caused by an organism called Mycobacterium tuberculosis. Now, this bacteria is slender, it's a little bit slightly curved, acid fast bacilli. Obviously, how it will appear like pink bacilli in blue background. Now, let's talk a bit about pathogenesis of TB. There are 7 steps I want you to remember. The first step obviously will be entry into macrophage. If we consider this as a cute little macrophage with big eyes and a little bit of smile, and it has 2 horns here, and this creepy creature as our TB, it enters the macrophage. Now this it does by a process called phagocytosis. Can you see these 2 horns here? These have names. One is called mannose binding lectin. The other one is type 3 complement receptor. These 2 are nothing but receptor. Is over. Now the bacteria has to replicate, right? So the next step obviously is replication. See, you already know 2 steps. Now TB bacteria, I'm sorry, I have to change the color. The bacteria is very sneaky creature. It is very smart. After it enters the macrophage, which has 2 horns, and what are they? One is mannose binding lectin and other is complement receptor. After it enters by a process called phagocytosis, sorry about that, it does 2 works. The one is, remember, one as P and other as PL. One, it inhibits the maturation of phagosome. The other is it inhibits the formation itself of PL represents phagolysosome. How do you think it does this? I told you, right, what is TB? It's a sneaky creature. Remember, this is us, not us, a patient on TB. The person is this. He got infected with Mycobacterium tuberculosis. Now, there's a protein called chronin. Remember, chronin? TB uses this protein, which is actually a host protein. Whose protein? It's a protein of this person. It's a host protein. It uses this protein and activates an enzyme called phosphatase calcineurin. What does it do? It activates an enzyme called phosphatase calcineurin, and this enzyme inhibits the formation of PL. It's quite simple, right? What did we learn so far? We have learned that it enters the macrophage. It has two horns whose names you remember by now. Then it replicates. Now how is TB? It's sneaky. It uses two processes, P and PL. And how does it do PL? It uses host protein itself, and host protein is chronin, and it activates an enzyme called phosphatase calcineurin, and this inhibits the formation of phagolysosome. Now the next process is innate immunity. But remember here, until this 3 weeks, there is no immune response so far. So how will be this guy who is sleeping peacefully here? He has TB, he is asymptomatic. But since the bacteria is increasing, it is maturing, it is replicating in the macrophages, there will be bacteremia, and there will be there will be seeding in multiple sites. Now let's talk about the third process, which is innate immunity. At last, the body recognizes something is wrong. Okay, so how is our bacteria? It's a sneaky person. It produces something called multiple pathogen associated molecular proteins. Let's remember them as MP, AMP, that is MPAMs. Now, these multiple pathogen associated molecular proteins bind to TLRs. TLRs are, if you know, toll-like receptors. Let's draw a cute little diagram for you to remember properly. Remember this. This is a chair. Okay, it's not a chair. It's a receptor. And this is another receptor. Now, let's call this as TLR2. And let's call this as TLR9. There's something called, it's a very tricky name. Of course, you'll remember it. It's called Mycobacterial lipoarabinomannan. Mycobacterial lipoarabinomannan. It binds with TLR2. This is one of these MPAMs. Okay, cool, right? The other one is called unmethylated CpG nucleotide. It binds with TLR9. See, if you remember CpG, and if you reverse this P, it appears as 9, right? You can remember it like that. And the other one, it will bind to TLR2. Now, if you remember, you can remember this, that this will activate the dendritic cell, and that will produce interleukin 12, which is very important. Coming to the fourth step, that is the Th1 response. Till now, the innate okay, now what happens is, let's say about after 3 weeks, this bad sneaky little microorganisms of Mycobacterium tuberculosis, they decide to come to the lymph nodes. These are lymph nodes. So basically what happens in this step is, the T helper cells, they activate the macrophages. are baby macrophages. Yeah, these are the macrophages. Let's draw them first. So now what happens? There are something called APCs. APCs are nothing but antigen presenting cells. These antigen presenting cells present the antigens, obviously. They also produce something called IL-12 and IL-18. Now IL-12 and IL-18, these are important for the differentiation of TH1 cells. Now if you remember, I was telling you something about IL-12, that the dendritic cells produce IL-12. Now this, after the differentiation, they activate the macrophages and then they become bactericidal. And that completes our fourth step. Let's talk about the fifth, sixth and seventh steps in the next video. Hope you liked it. Do share and comment. Thank you.